All right, good morning, good afternoon, good evening. Whenever you watch this video, I appreciate you tuning in. Looking forward to working on some substitution with you guys real quickly here. Don't want to take up too much time, but I definitely want to make sure that whatever we practiced in the previous to today, we want to solidify that understanding today, okay? And as I remember from our previous classes, I feel like some of you got it down really well, okay? And so really, as I go over some things here, if you want to fast forward through it, I'm okay with that. But I do recognize that some of you are still struggling to use this substitution method, and I want to make sure that we get that down. So here's what we're going to do. As we look at the title here, 6.2b substitution method, you can look down through that. I mean, this is basically everything that we're doing. It shows you can graph it. We've talked about that before. Or you can use algebra, which is what we're kind of focusing in on now with that substitution method. But what I want to do here, we've actually already done these first three problems here. So I'm actually going to get rid of those first three. and I want you to do, I want you to do a different problem with me that's actually harder than any of the ones that we've worked on so far. So you can go ahead and scratch those out, get out of here. I don't need you, okay? And I want to take a look at an example that's really harder than any of the ones that maybe you'll even have on your homework tonight, okay? But this is where we're headed, and if you can do this type of problem, you're pretty good. So here's the problem. The first equation is going to be this. 4x plus 2y is equal to 8. And your other equation is going to be 7x minus 5y is equal to 14. Okay. Now at this point in time, as I look at those two equations, we've had this discussion before. You need to identify a variable that you're going to solve for. You need to identify which equation you're going to solve for that variable in. Does it matter which variable from which equation you solve for? Absolutely not. It does not matter. However, it does matter if you want to make things easiest for yourself. If you want to make things easy, I'm going to choose a certain variable a lot of times. So as I look at this equation, these two equations, and I look at these down here, I'm like, oh boy, 5 doesn't go into 7, 7 doesn't go into 5, 7 goes into 14, that's good, but 5 doesn't go into 14. So this equation, I'm going to stay away from that one right there, okay? As I look up here, well, 2 goes into 4, 2 goes into 8. I'm probably going to go ahead and solve for this variable right here. I think that's the easiest one to solve for. And that way I'm going to have something without fractions and I can plug it into the other equation. So let's see how this will play out. If I want to get 2y by itself, what am I going to do to both sides? Well, I'm going to go ahead and subtract the 4x to get it over there, right? So if I subtract 4x from both sides, you have this. 2y equals negative 4x plus 8, okay? So minus 4x plus 8, okay? Now from there, if I want to solve for the y, so I can plug it in this equation down here, I'm going to divide both sides by 2, okay? Now don't forget to divide both these terms by 2, so you end up with y equals negative 2x plus 4, okay? Now I'm going to take this expression, which is y, this right here, and I'm going to plug it in for the y value over here. Now remember, when we did that the other day, if I rewrite this down, 7x minus 5y okay? Remember, you have to multiply everything, all of y, okay? Not only is this y right here, the negative 2x, but the 4 is also y. So you need to multiply both terms by this negative 5 here. Remember, it's negative 5, okay? So if I do that, we get this. 7x equals positive 10x. Negative times negative is a positive. And then we get negative 20. 5 times 4. Okay? Now it becomes a real simple equation to solve for x. So if I do that, I get 17x. 10 plus 7. I'm going to add 20 to both sides to get 34. Okay? And then if we divide both sides by 17, what's 34 divided by 17? That's 2. That's beautiful. Yes. Okay. So I know x is equal to 2. Okay. Now, what does y equal? Well, if I take this and I plug it in over here, I know that y has to equal -2, it's a -2 here, times the x value I previously found, which was 2, we found that down here, okay, plus 4. All right, so in the end, we get -4 plus 4. What's -4 plus 4? 0. So my equation, 2, 0. Okay, that's my ordered pair for that type of problem. So if that all made sense to you, you're going to be kicking butt the next couple of days. You should be doing just great. Okay, that's a lot of work right there. I've got some sophomores and juniors in geometry that are struggling with that. So it's not hard, just take it step by step. And I know I went through that kind of quickly. Why? Because it's recorded. You can go back and look it over. Okay. Now, I do want to go over to the back side and look at these with you. These are actually easier problems on the back side. But in doing this, this is more for those of you who are struggling with this, and we want to make sure that we get these down, okay? If you feel confident in solving these type of problems, by all means, go ahead and do it. You know, refer back, make sure you've done them correctly before the end of the period, hopefully. But that's my goal here. I'm going to show those that are struggling with this how to do these, okay? Up here, we've got x already equal to 2y. Well, that's simple. I'm going to plug this value in for the x right there, okay? I'm going to change my color because that black's just blending in a little bit too much for me. Change it to red, okay? So if we do that, I'm going to change this to a fraction. If you don't have to, but I'm going to go ahead and do that. I end up with 1/4 of 2y plus half y is equal to 10. Okay. Now, what is 1/4 of 2? Well, half of 2 is 1, so 1/4 of 2 is a half. So this is a half y, just multiplying these two together, okay, plus 1/2 y is equal to 10, okay. So what is a half y plus a half y? Well, we get 1y. Well, we already know that y is 10, okay. Now to solve for the x, I'm just going to take that back and plug it into the other equation there. If I do that, let's see here, plug this in here, we get x is equal to 2 times 10, which is going to be 20. So x is 20. I'm going to write it down like this. X is 20 and y is 10. Okay. Now there is always a way to double check this. I know that I've plugged these two values in here and here, and those two answers, these two, satisfy this. Okay. But if I wanted to double check it, I could always plug it in right here. So if I took 1/4 of the x, which is 20, 1/4 of 20 is 5, okay, and half of y is 10. Well, what's half of 10? Well, that's 5. Does that equal 10? And it certainly does. And so, again, that's one way of double checking your work, plugging it into the other equation as well. Okay? All right, let's take a look at the next one, number 5. A little bit more complicated because we're changing here from, let's get rid of this, get out of there. We're changing from the fact that we're already given what the variable is equal to now we have to solve for a variable. Now, I want to tell you this. I'm definitely solving for the x's here, okay, in either one. It doesn't really matter. But from what I see, I like to solve for this x better than this x because if I do that, moving this to the other side, I'm going to add 2y to both sides. So you end up with this. If you were to move this guy to the other side, you'd be subtracting him from both sides, and you'd end up with 2 negatives. Now, it's going to work out. It's fine. But at the same time, you know, some of you don't like those negatives or like to work with the negatives. That's one way to not have to do that. So now what I'm going to do is I'm going to take this guy, and I'm going to plug him in right there. okay, because that is what x is. So if I do that, I have 2y minus 5 plus 2y, okay, so this was the x right here, all of this, okay, plus 2y is equal to negative 1. If I combine like terms, 2y plus 2y, this is a negative 5. To get into the other side, I'm going to add 5. 5 minus 1 is 4. Oh, that looks pretty, doesn't it? Divide by 4, divide by 4, y equals 1. Okay, so that's good, that's easy. Now I can go ahead and plug this guy back in here, this y equals 1 right there. X will equal 2 times 1 minus 5. Okay, 2 minus 5 is negative 3. So my ordered pair is negative 3, 1. Okay, so again, just working through those. I know I'm going kind of fast, but it's almost 9:40 at night, and I want to get home. So, but I can double check these. If I plug the negative 3 in for the x here, negative 3, we already know that that satisfies that problem. So these are good for this equation, this one right here, the top one. The bottom one, let's see if it works out for the bottom one. If I plug in negative 3 here, plus 2y, what was y? Y was 1. Does that equal negative 1? Well, negative 3 plus 2, that does give us negative 1, so it does check out. Okay? So, remember what we're doing here is this. Substitution is basically telling us where are the x values the same and where are the y values the same. Okay? Remember, we started this whole section by graphing. Okay? So you had this grid right here, right? And you graph this, and you had the line that went like this, and line that went like that, and this was the answer, right? Okay? Why is that the answer? Because the x values here, whatever the x value is, let's say it's a 5, and whatever the y value is here, let's say it's 4, okay? They're the same in both the equations as they pass through there, the x value and the y value are the same in both equations. So that's what we're looking for, where they cross, okay? All right, let's look at the last one right here. Taking a look at the last problem here, I want to go ahead and solve for one of the variables. Now I hope, as of right now, you're thinking to yourself, I probably want to solve for the y's here. Okay, they don't have anything next to them, be real simple. Okay, and so which one of these equations would I solve the y for? What I think is smartest? It's probably this one right here. Because I know that to get this guy to the other side, he's a negative right now. So to get him to the other side, I have to add him. So I'm going to go ahead and do this. Okay, I have this right now, 0.2x plus y is equal to 0.5. Well, I'm going to go ahead and add him to both sides. Get rid of that, sorry. Plus 0.2, and you end up with y equals 0.7. Oh, what am I doing? Goodness. I just made a mistake. It must be getting late. Okay, can I add those two together, 0.5 and 0.2? No, why not? Because they're like terms, okay? They're not like terms. I need to have like terms. This should have been adding a 0.2x, okay? This one has an x, that one doesn't. They're not like terms. So it should have been 0.2x plus 0.5, okay? All right, now, I can then take this, which is a y. Remember, it's equal to y, so this is y. And I can plug it in for the y right there. There we go, okay? So if I write that out, I get 0.4x plus 0.2x plus 0.5 is equal to 1.1. Make sure that we don't get confused with that over there. Okay? Now again, kind of this real simple equation. We just want to combine our like terms. 0.6x, 4 and 2 make 6. I'm going to go ahead and subtract 0.5 from both sides. Gives me 0.6. Beautiful again. Divide by 0.6. I get x is equal to 1. Awesome. Okay. Now from there, if I plug that in there, y equals 0.2. Now this is a 1, right? 0.2 plus 0.5. And so my ordered pair for that is going to be 1, 0.7. Okay? All right, folks, you've been a great audience. Like I said, I feel like most of you have that down. I hope that you're understanding the algebra that I'm working on here. Okay? When they're on the same side, like these are, I still see some of you changing signs. Don't change the signs. They keep the same signs, which is why it becomes 0.6. You want to take this guy to the other side. Make sure you switch the signs. When we flip sides, we flip signs. Okay? All right. You have your homework, which is just below here. If you have any questions, we can come back and talk about it tomorrow. But again, I believe that there's a lot of other people in the class that can help you out if you need help. I hope to see you tomorrow. Have a great night. Goodbye.